third example, we have y double prime plus 9y equals tangent 3t. This has an associated homogeneous equation, yh double prime plus 9yh equals 0, or lambda squared plus 9 equals 0, which gives us lambda equals plus or minus 3i. This gives us a y1 of cosine 3t and a y2 of sine 3t. This is y1 prime of negative 3 sine 3t and a y2 prime of 3 cosine 3t. So instead of solving a system of equations, we're going to use the formula for v1 and v2. So to do that, we need to find the Wronskian, which is w of y1, y2. That's just the determinant of the Pauli matrix, y1 prime, y2, and y2 prime. That's going to be the determinant of cosine 3t, negative 3 sine 3t, sine 3t, and 3 cosine 3t. It's going to be 3 cosine squared 3t minus negative 3 sine squared 3t. These two negatives will create a positive. Factoring out 3, we get 3 times cosine squared 3t plus sine squared 3t, which is just 1 by the Pythagorean theorem. So the Wronskian equals 3. So now we can use the following equation to find v1 and v2. So v1 is going to equal the integral of negative y2 times the forcing term f dt over the Wronskian of y1 and y2. This is going to be negative sine 3t. The forcing term is tangent 3t, and Wronskian is 3. We can convert the tangent into sines and cosines and factor out the negative 1/3. That'll give us sine squared on top and a cosine on the bottom. Next, if we convert the sine squared into 1 minus cosine squared using the Pythagorean identity, and we leave the cosine down here, and then we distribute the cosine to the 1 and the cosine squared. It'll give us secant 3t minus cosine 3t. Integrating this, we get negative 1/9 ln secant 3t plus tangent 3t, absolute value, and 1/9 sine 3t. That's v1. And then v2 we find using the formula y1 f dt divided by the Wronskian of y1 and y2. That's going to be the integral of cosine 3t tangent 3t over 3 dt. Converting tangent into sine and cosine, we get cosine 3t sine 3t over 3 cosine 3t dt. Cosines will cancel, and we'll have 1/3 the integral of sine 3t dt. That's going to be negative 1/9 cosine 3t. So our y particular v1, y1 plus v2, y2. That's going to be negative 1/9 ln absolute value of secant 3t plus tangent 3t times, or plus 1/9 sine 3t, all multiplied by cosine 3t, minus 1/9 cosine 3t sine 3t. If you distribute this cosine to this and that, we see we get a 1/9 sine 3t cosine 3t, and a negative 1/9 sine 3t cosine 3t. These will cancel, so we'll be left with negative 1/9 ln secant 3t plus tangent 3t times cosine 3t. So our answer will be y of t equals c1 cosine 3t plus c2 sine 3t minus 1/9 ln secant 3t plus tangent 3t cosine 3t.
We try.